Good afternoon, teacher.
Okay. Let's start now with lesson 4, friction. After we talked about the friction, we will guess now which the type of a kinetic friction shown below. Before we start, what do you know about the friction? A friction is a force that opposes motion. Is it right? Is it a force that opposes motion?
Yeah.
Now, so what's the definition of a force? It is of friction. Sorry, it is a force between any two surfaces that opposes motion. So a friction is a force, like the gravitational force, like the normal force, like the push and the pull force. It is a force between any two surfaces that opposes the motion. Now, look at this block of wood here. This block of wood is pushing on the table. Now, which direction is the force of the friction? They push the table to the right. So what is the direction of the friction will be?
To the right. Left.
Left. Friction, it is opposes the motion. It is in the opposite direction of the motion. Since I push my hand to the right, so the friction will be to the left. So, why the friction occurs? The friction occurs because the surfaces are covered by microscopic hills and valleys. This, as an example, this is the surface. This surface is covered with like this valley and hills. This is a first surface. Another surface, it is with valley and hills. Now, between these two surfaces, since they are covered with microscopic hills and valleys, when they stick to each other, when they contact with each other, they make a friction. So why the friction occurs? Because there's a microscopic hills and valleys. This one, it makes the opposite objects, or it's resists them to move. Now, so the friction is caused by microscopic valleys and holes of the objects wrapped together, as we see in this picture here. Look at this wood here. Look at the wood. Look at the table. Between them, there's a friction. From where this friction happened, look at the object of the wood here. It comes from valleys and holes. The table, it comes from valleys and holes. When they are connecting to each other, when they are sticking to each other, there's a friction will happen. So how does the roughness of surfaces that are touching affect the friction between the surfaces? Rough surfaces have more hills and valleys. When you have more hills and valleys, that's increase the force of the friction. But the smooth surfaces have less hills and valleys, so there's a less friction. So as we know, there are two types of surfaces: rough and smooth. The rough surfaces have more friction. Why they have more friction? Because they have more hills and valleys. But the smooth surface have less friction. Why? Because they have less hills and valleys. That's how the roughness affects the friction. The roughness surface have more friction. The smooth surface have less friction. Now, here if you look at the previous picture here, we have this smooth with this microscopic valley and hole. And if you look at these objects here, we have also between these two surfaces, we have valleys and hills. But who will have more friction? This picture that is between the wood and the table, or between these two surfaces? Which one? Which one has more friction?
The first one.
This one. Why?
The first one, surface A and surface B.
This one.
It's
Why?
more rough.
Because if you
Because
have,
it's more rigid.
yeah, since we have larger hills and valleys, so that's mean we have more So, since now these two surfaces have larger hills and valleys, so they have more frictions. So they are roughness than they are more rough than the other one. Now, when you push the two, imagine now you have two, like this picture here. You have two objects. Okay, if you push the same two surfaces at the same time, but with different force. If you push here with 5 Newton and the other one with 1 Newton, which will have more friction? The one with which is pushing with greater force or with a smaller force?
The more force, the more friction.
Yeah, they're proportional.
Yeah. So if the force pushing the two surfaces is large, so the hills and valleys are in closer contact, so the friction will increase. What does it mean? Look at this picture here. Look at the first one, how when the force is very large, is greater. Look at how the valleys and the holes are contact with each other. They are closer to each other, so they are make more friction. But in the second one, they have less friction than the first one. So more force, more friction. More valleys and holes, more friction. So what does it mean? That's mean, or we can conclude that we have two ways that can make the friction increase. What are these two ways? Make the surface rougher, make them have more valleys and holes, and push the surfaces harder, act with them in a greater force. Is it clear?
Yes. Yes.
Okay. Now, let's talk about the two types of friction. The two types of friction here are kinetic and static. Kinetic friction and static friction. The kinetic friction, like when you slide a book across the tabletop. Kinetic, meaning when the object is moving. So sliding a book across the tabletop is a kinetic. Static, like if you push a piece of furniture and it doesn't moving. Oh, it's not moving, sorry. This is kinetic, when the object is moving, and while it's moving, it has a friction. And static, that's mean if you are push something and it didn't move. And there are three types of kinetic friction. sliding, rolling, and fluid. Sliding, like when you move a book across a desk, when you slide the book, or applying brakes on a car, or scratching your arm. These are examples of sliding kinetic friction. Rolling, from its meaning, like the wheels of the bike, the wheels of a car, toy car, trains on a track. The wheels are rolling, so they make a friction with the surface. This type of friction is kinetic because it's moving, and specifically we call it rolling kinetic friction. The last one is fluid kinetic friction, like the oil lubricating parts on a plane, or in the bike, or the water flowing through a hose. Here you have a hose, or you can say like a pipe. When the water is flowing inside the hose, they have a fluid friction. If you come back to the first picture here, here, look at it. Is it a kinetic or static? It's a kinetic.
It's kinetic.
Since the bear is moving. Is it a rolling or sliding or fluid?
Sliding.
Sliding.
Thank you. This is for the definition of the friction. Is it clear?
Yes.
Yeah.
Okay.
Yes, teacher.
Now, so by now, we know that for any object, while it's moving, we have a gravitational force downward, normal force upward, push or pull force up to the right as an example, and there's a friction force to the left. So imagine now there's a box here, and this box is sliding on a, when I told you this is a sliding, that means it's moving. I'm talking about kinetic motion. Now, so for this one here, we have an normal force upward and gravitational force downward. There's a push force, we name it with F1 to the right, and there's an frictional force or friction force to the left. So these are the four objects, the four forces that acts on this object. If the forces sorry, now if you want now to when the force when the friction force just balances the applied force, if the force, the acting force, this one here, is equal to the frictional force, so the net force will be 0, and the object will not move. That's we call that static friction, or sorry, no, it's not static. Here, when the net force is 0, when the force, the acting force equal to the frictional force, that means the net force here is 0. Is it accelerating? If the force is not, if the object is not moving.
Teacher, why isn't it static friction? What is static friction?
The static, that's if you push the object and it's not moving. This is the static.
So my applied force is less than the friction force.
Yes.
Can you, what did you say about the static?
Static means that I apply a force, but the object will not move.
Oh, okay.
This is the static.
That's static.
Here, when apply a force, and this force equal the frictional force, so the net force is 0. As we know, from the right minus to the left. If the net force is 0, is there an acceleration? Look at this formula here. F is m times a. If the net force is 0, is there any acceleration?
No.
No. So when the net force is 0, when the friction equal the force, the applied force, so there's no acceleration. The object will not move. What about now? If the applied force is greater than the friction, so the object will move. Is it right?
Yes.
So when the applied force is greater than the friction, here we have the object will move. So we have to find the F net, or the net forces, which is equal m times a. Now, let's see now how can we represent the forces acting on an object. To represent the forces acting on an object, we have something we called it free body diagram. The free body diagram that I will sketch, or I will represent the forces. Sorry. This is F. This is a friction. This is an F, no, for normal force, and this is the gravitational force. Now, for this one here, if I asked you now to find the resultant force on the x-axis, what did you say?
The
Cosine, right?
sine
Yeah,
plus
F
cosine.
minus F friction. Is it right?
By f of x.
Sorry?
What do you mean by f of x?
The resultant force on the x-axis.
Ah, okay.
Oh,
Is
yes.
it F minus F friction? And the resultant force of the y-axis is
It's
the
the normal
n
minus
minus f here.
F gravitational, yes. Then, after you find Fx and Fy, if I ask you to find the acceleration on the x-axis, or a sub x, know that from here, F is m times a. So a is F over m. So a, the acceleration on the x-axis, will be the resultant force on the x-axis over the mass, and a sub y is the resultant force of the y over the mass. Who leaving the class? Lama, is it right?
I think she had a problem.
Lama. Okay. So here you have more forces acting, or many forces acting on an object. To represent these forces, you have to use the free body diagram. From the free body diagram, you can find f of x, or the resultant force on the x-axis, and the resultant force on the y-axis. And if I ask you to find the acceleration on the x-axis, you will say that it is the summation of the forces on the x-axis over the mass, and the acceleration on the y-axis will be the forces on the y-axis over the mass. This is the main idea.
Teacher, just a minute, don't erase it. I'm done. Yeah.
Okay, thank you.
Thank you, teacher.
Now, if you have now an object like this, and this object now, there's an acting force equal 1 Newton to the right, and the friction force is unknown. They told me that you have a constant, or the velocity is constant. Find the acceleration. Then find, or without this talking, okay. Find f friction.
If the velocity is constant, why are they asking about the acceleration?
Yeah.
The acceleration will be 0. That's mean I want to ask to tell you about it. So if there's a constant velocity, what about the acceleration?
It will be 0 because
Zero, because no change velocity, no
If
acceleration.
the acceleration, or if you say that fms times m times a, and if the acceleration of 0, what does it, the net force equal?
0.
It will be 0. So since now the net force equals 0, can you tell me what is the net force here? Oops. What is the net force up here?
0.
It is F minus F friction. And this, the resultant force is 0. So the F applied equal the friction. So the friction force will be 1 Newton. Okay, I will repeat now. Here you have an object. And this object, the applied force is 1 Newton. And this object, it has a constant velocity. Constant velocity that means 0 acceleration. Now, 0 acceleration, what does it mean? That means the net force is 0. Now, since the net force is 0, keep it in your mind. Come back to our box here. What is the net force?
1.
The net force here is the forces on the x-axis. Then, so it is F minus F friction. Now, since the force here is 1 Newton and the F friction is unknown, but the net force is 0, so the F friction will be 1 in Newton.
Oh, okay. Thank you, teacher.
You are welcome. Excuse me, tomorrow, inshallah, I will continue our lesson. We will talk about more examples for the pivot diagram. Okay, I have to stop here today.
Okay, teacher.
Okay, thank you
Okay.
so much. Bye bye.
Thank you, teacher.
Bye,
Bye
teacher.
bye.